हाँ जी, अब हम आ गए जी क्वेश्चन नंबर 22 पे। ठीक है, क्वेश्चन नंबर 22। वी आर स्टार्टिंग क्वेश्चन 22। A small spacecraft known as Beagle 2 is to land on planet Mars. To solve this question, any information about Beagle 2 is needed? No, it's not needed. The question will use multiple names, multiple general knowledge things, but they are not needed. They will test your physics knowledge that you have learned in the class. So what is Beagle 2? Which planet is planet Mars? This information will not be needed in the question. In the question, they will test your physics knowledge only. Everything will be given. No memorization or general knowledge is needed. Now, as the spacecraft enters the planet's atmosphere, no, if a student has no idea that Mars has some atmosphere, it's not an issue because they're telling that. They will tell everything. It slows down because of obviously the resistance provided by the atmosphere. When the speed reaches 1600 kilometer per hour, parachutes open and the friction with the atmosphere increases. The spacecraft eventually reaches a steady speed and then finally it hits the surface. Now, on the axis of figure 1.1, complete the speed time graph for the spacecraft. They are saying that on figure 1.1, you need to complete the graph of speed time for the spacecraft. However, they have given some information. The parachutes open at time t1 and the spacecraft hits the surface at time t2. Now, when the parachute will open, the air resistance will have a sudden increase and the speed will decrease at an abrupt rate. Basically, the deceleration will increase. And at time t2, the spacecraft has to stop because it is going to hit the surface of the Mars. So T1 is the time when the parachute will open and air resistance will have a sudden increase. And one thing should be clear. Even before time T1, the air resistance was bigger than weight as the spacecraft has a deceleration. Now, with opening of parachute, the deceleration will become abrupt and as the speed will decrease, the air resistance will also decrease because it depends on the speed. Up to T2, this graph will continue until it hits the surface. So we have decreasing deceleration, and on time T2, it will hit the surface of Mars and it will have a sudden stop. The spacecraft will have a sudden stop at time T2. So this is graph of speed versus time after opening of parachute. Now next part. The mass of the spacecraft is 65 kg. At one point, the gravitational field strength of Mars is 3 Newton per kg and the total upward force on the spacecraft is 500 Newton. Determine the weight of the spacecraft. Basically, if we look at the situation, gravitational field strength is 3 Newton per kg. They have given this 3 Newton per kg. Mass is 65 kg. Now we can use this information to calculate the weight of the spacecraft on the planet Mars. So W is equal to m into g. As you see, m is 65 kg and acceleration due to gravity on Mars is 3. So 65 into 3 should be the answer. So if we multiply 65 with 3, we are getting 65 into 3, it's 195. So the weight of the spacecraft on Mars is 195 Newton. So here we will put 195 Newton. The resultant force on the spacecraft. So they are asking that what is the resultant force on the spacecraft that will become, you see there are two forces on the spacecraft. One force is the weight and one force is the resistive force. They said that the total upward force or the resistive force is 500 Newton. So the upward force is 500 Newton and the downward force is the weight that is 195 Newton, which means that the net force is upward. As a result, it will be resultant force is equal to weight 195 Newton that is in the direction of motion because the motion is downwards. and opposing force is bigger. That's why it is decelerating. So 195 minus 500 will get a negative answer because of deceleration. The resultant force is opposite to the motion. So 195 minus 500, and we are getting an answer of negative 305. The negative sign shows that it is opposite to the motion. The force is decelerating or opposite to the motion. That's why it's negative. However, in the answer, the negative sign is optional. Since force is a vector, so for vectors, the negative sign shows the direction. While writing the magnitude, you can ignore the negative sign. So it is 305 Newton. Now, the next part is the acceleration of the spacecraft. So we have to calculate the deceleration of the spacecraft. Deceleration will be obviously A is equal to F over m. Since the resultant force is negative or opposite to the motion, that's why we are getting a deceleration. So it's negative 305 over mass of the spacecraft is 65. So it will be 305 divided by 65. And the answer that we are getting is 4.626923 and meter per second square, and it will be negative since it's deceleration. However, in the answer, this negative sign is optional since the examiner has given the word deceleration. The negative sign shows the deceleration. When it is written to be deceleration, the negative sign is not compulsory, but it's optional. So you can write 4.69 and unit will be meter per second square. You can ignore the negative sign because the word deceleration is already written.